Hello everyone, it's time for physics today. We start on Unit 9, Sound. So when a disturbance happens in a medium, information about that disturbance is transmitted as pressure variations in that medium. Well, what does that mean? So, for the number one thing there is that for sound to happen, there needs to be some sort of medium, something for the sound to travel through. Okay, so let's look at it. Let's look at just a brief example, like someone clapping. So I'm going to represent that disturbance as a single point. Okay, I'm going to represent that clap as a single point. In order for someone standing over here to be able to hear it with their ear, there has to be some sort of substance, something in the middle here that sound can travel through to hit the ear. If we were in space, well, you wouldn't be able to hear someone clapping or shouting or anything like that because there's no medium for the sound to travel through. This medium could be anything from air or water or a steel railroad track or anything like that. Let's look at a little bit closer of what sound actually is and what's physically happening when sound travels through a medium. So what we're going to do is we're going to look at the pathway of information from my vocal cords to your ears, and we're going to make some stops along the way to see if we can learn a few things about sound. Vocal cords move back and forth, creating a disturbance in the air. So when this diaphragm moves up, it's going to compress the air in front of it, and when it moves backwards, it's going to decompress the air in front of it. When this repeats over and over again, we get a sound wave. I'm going to simplify my vocal cords as a simple speaker, and that's just a diaphragm that's able to move back and forth. And when my vocal cords move back and forth, they create a disturbance in the medium of air. And when my vocal cords move up, it compresses the air in front of it, and when it moves backwards, it decompresses the air in front of it. When they move up, it's going to compress the air in front of it, and when it moves back, it's going to decompress the air in front of it. When this disturbance happens over and over again, very, very fast, it creates a sound wave. And what a sound wave is areas of compressions and rarefactions in the air. The more dense areas here, I'm going to call the compressions, and those are areas of high pressure. And the areas of low pressure then are called rarefactions. So areas of high pressure are called compressions, and areas of low pressure are called rarefactions. And again, that's a result of my vocal cords creating a disturbance in the air. Keep in mind when we're talking about sound, if we pick a single particle here, this particle didn't travel from here to here. This particle is only moving back and forth. It's only moving back and forth, kind of like this. Okay, so when you have a particle moving with the direction of wave motion, what type of wave is then a sound wave? If you don't know this answer immediately, pause the video and go find it. So remember that waves carry information about that disturbance. So the next place that our sound information is going to stop is at the microphone in my camera. Now a microphone acts kind of the same way as a speaker. It has a diaphragm that's able to move back and forth. So the diaphragm in the microphone, the air moves the diaphragm and the microphone back and forth in a similar way that my vocal cords move the air back and forth. This back and forth motion in the diaphragm of the microphone is then transferred to electrical energy and stored as data on my computer. So the microphone picks up the pressure differences in the air and converts that into digital data, and my computer can store that. Of course, after that, then I'll upload this video to YouTube, where then it will also be stored in one of their servers there. That information will then be accessed by your computer, and your computer has either speakers or maybe you're listening to some earbuds. And in those earbuds, there is another speaker. So when you watch this video, that digital data of my voice will be transformed back into a sound wave when it leaves your computer speakers or your earbud speakers. Those speakers will vibrate the air in the same way that my vocal cords did, and your ear will pick up that information-saturated disturbance. The next stop for our sound information is going to be in your ears. The vibrations of the earbud will cause a disturbance in the air that will cause your eardrum to vibrate in the same way, and then through a process of 3 small bones in your ear and a thing that looks like a snail, that information gets transmitted into electrical signals, which is then picked up, of course, by your brain. Your brain can't understand pressure disturbances in the air, but your ears can, and can transform that data into electrical signals that your brain can understand and interpret. You receive that information that started out. So just to review, my vocal cords cause a disturbance in the air that carries with it some sort of information. When a sound wave is traveling through the air or any other medium, there are areas of compressions of high pressure and areas of what are called rarefactions or low pressure. Okay? When those compressions and rarefactions hit a microphone, the diaphragm in that microphone is allowed to move back and forth and vibrate in a similar way that my vocal cords did. That information is then transformed into digital data and stored in my computer, which then I upload to YouTube. When you access the video on YouTube, that sound information will be stored on the video. And when you listen to the video, the little speakers in your earbuds will move back and forth in a similar way that the microphone picked up the air that my vocal cords caused to move. Okay? The earbud will vibrate in such a way, will cause a disturbance in such a way that that information will be transferred into your ear, and through a series of very interesting other things that happen, your ear is able to transform those pressure variations into electrical signals that is interpreted by your brain. The journey of sound from my vocal cords to your ears are very long, and we are fortunate enough to live in a time where we have the technology where this can happen.